Hey, multiplying complex numbers is not a big deal at all as long as you remember that we have to sort of distribute all the terms and the key fact that I squared equals negative 1. Let me show you what I mean with an example. So let's multiply 3i by the complex number 1 minus 5i. All I'm going to do is just distribute. So I'm going to distribute that 3i. And what I see here is 3i times 1 minus, and then I have 3i times 5i, that's 15i squared. But remember that I squared is the same thing as negative 1. So now I've got a negative here and a negative here, so that's just 3i plus 15. And we traditionally write the real part first, so I'm going to write the 15 plus 3i. So the product of these two complex numbers is the complex number 15 plus 3i. No problem. Let's sort of up the ante a little bit, see how we'd multiply these two complex numbers together. All right, so here we have to be a little bit more careful. We've got to do lots of distributing. So we first multiply the first two. 2 times 5, that's 10. Then the outside terms here are going to be 2 times negative 4i. That's going to be negative 8i. The inside terms produce, when I take the product, a negative 15i. And the last times the last, the negative times the negative is a positive. 3 times 4 is 12. 12i squared. But wait, I squared is the same thing as negative 1, so I see a 10 minus 8i minus 15i minus 12. And now we combine like terms. We combine the real parts and the imaginary parts. So when I combine these two together, I see just a negative 2. When I combine these two, I see a negative 23i. So you see, it's a couple of steps involved, a couple of steps that are involved, and then we have to combine like terms, the real parts and the imaginary parts, and then we're set. The answer to this product has an answer of negative 2 minus 23i. You want to try another one? I know you do. 5 minus 2i times 5 plus 2i. 5 times 5 is 25. The outside terms produce a plus 10i. The inside terms produce a minus 10i. And the last times the last produce a minus 4i squared. Well, I squared is just negative 1. So I see here 25 plus 10i minus 10i, they actually drop out. Look at that, they cancel. And I'm just left with a negative, and then the negative 1 here gives me a plus 4. And so I see 25 plus 4 is 29. Notice that the answer happens to have no imaginary part. This is actually just a real number. And if you look really closely, you'll notice something interesting. You'll notice that this number is related to that number. In fact, this number is the complex conjugate of this number. Really? Well, remember, all that means is that I switch the sign of the imaginary part. This is a really cool and important fact, that if you take a complex number and multiply it by its complex conjugate, the answer is always going to be a real number. Remember that. It's going to be useful in a little bit. Now, let's try one last example. Okay, so 7i times 7i. So what is that? Well, 7 times 7 is 49. I times I is I squared. But of course, I squared is just negative 1, so this is just negative 49. Couldn't be easier. Neat. So the point is, when you want to multiply two complex numbers, it's not a problem at all. You just have to make sure that you do all the distribution issues in there, and that you combine like terms, putting together the real parts and the imaginary parts, together with the final fact that whenever you see an I squared, that equals negative 1. It becomes real. Other than that, you're all set to go. Just take your time when you distribute.